Alright, I got to talk a little loud and make sure you understand how to do this. So what we're talking about right now, this is the Pythagorean Theorem. Now, I'm not talking about where it comes from. I'm not talking about why it is the way it is. All I'm talking about is how to do it and what to set it up. Alright? So I have two examples right here. We can call them 1 and we can call them 2. I'm a little backwards. Sure. That's 1, 2. I'm a little left to right. Sure. Right to left. First thing you want to do, write out your equation. A squared plus B squared equals C squared. Okay, write out your equation, the relationship for this right triangle. This equation only works for right triangles, okay? So the next thing you're going to ask yourself is, what is C? Well, C is always the hypotenuse. So on this triangle, you're like, well, which of those numbers, which of those sides is my hypotenuse? Go to your right angle and go right across from that right angle. That is your hypotenuse. Okay, it's the side that doesn't touch that right angle. It's the side that is opposite of that right angle. Take your pick of how you want to describe it, but that hypotenuse is directly across from that right angle. So I know that this number right here is going to go in place of C. All right? The rest of it is filled in with the other two numbers, x and 7. Now, because this is addition, it doesn't matter which way we put it. I could put 7 here and x here. That's fine. I could have switched it the other way. That's fine. Now, the purpose of this is now I want to figure out what that missing side is. So I'm going to solve the equation for the missing side. So simplify your expression by taking care of those exponents. 10 squared is 100. And keep your equal sign there. X squared. And you're adding here. 7 squared is 49. It has got me one step closer to finding out what x squared is. I want to combine my like terms, so I'm going to take that 49 and subtract it from both sides of my equation. That's going to leave me x squared all by itself. So if I subtract 49 from both sides of this equation, you end up with x squared by itself, because 49 minus 49, that's 0. And anything plus 0 is just itself. 100 minus 49, that's 51. Well, the last thing you're going to do, because you can't just have x squared there, you want just x by itself. So we're going to take the square root of both sides, all right? So if you take the square root of a squared number, it just gets you that number. And then you take the square root of 51. Now, for all intents and purposes in this class, leave it like that. Otherwise, plug in your calculator, give me 2 rounded decimals, that's fine. Now, I showed you this example, but there's some of you who might still be confused, so let me show you a different example. What if I don't know what the hypotenuse is? Same deal, write your equation, a squared plus b squared equals c squared. That's fine, all right, so you write your equation out. Find your hypotenuse, it's right across from that right angle. Happens to be x this time, so we say, all right, x, that's my hypotenuse, right? Well, the other two numbers, it's okay, you can put them in any which way. Once you have it written in, you simplify. Again, we're going to start with the exponents. We're going to simplify those exponents by squaring both these terms. So 4 times 4 is 16. 3 times 3 is 9. X squared is x squared. Now, I'm going to go ahead and add these because they're already on the same side of the equation. Over here they weren't, so I had to subtract them. That's all right. Over here, they are on the same side, so let's add them. That's 25 equals x squared. That's nice. I still, again, want to take the square root of both sides of my equation, so that x squared is not x squared, it has to be x. So if you take the square root of a square number, it just leaves it by itself, and take the square root of 25. Now if you left it like this, like I said, it's fine, it's okay, but I know by memory, square root of 25 is just 5. Alright? So there's some steps for you on the Pythagorean theorem. Good luck. See you later.